Hello, this is the overview video for the 2019 Collins Aerospace NDSU Capstone Project. Our team members are myself, Jeremy, Eli, Alec, and Ian. Our mentors for the project were Mike and Steve. Collins Aerospace is an aviation-based company specializing in technological solutions for the global aerospace and defense industry. Collins Aerospace uses crates as defined in the ARINC 827 specification document to transfer loadable software parts and files into an aircraft. Our project is to create an API-driven application that allows users to input various loadable software parts, directories, and other files, which will be created according to the ARINC 827 specification document. On the other side, users that receive the crate can also pass it to the API to verify that it has not been corrupted or tampered with in any way during the file transfer. Our application, along with various documentation and testing metrics that we gather, will provide Collins Aerospace with a framework to implement ARINC 827 crating into their own systems. To help understand the purpose of our application, we can make an analogy with a cake. Imagine a baker sends a cake to a customer, but a mischievous third party intercepts the cake and adds cyanide before passing it on to the customer. If the customer just blindly accepts the cake, they could be poisoned. Our project's purpose is to make sure that we are able to identify if a third party has tampered with the cake. We would not prevent the cake from being poisoned, but we would simply verify whether or not it was poisoned once the customer receives it. We will now show a demo of our application, using a basic web form to demonstrate our API functionality. Our API is running in a portable Docker container, currently hosted on Amazon Web Services. As you can see, our API has the capability to take in loadable software parts, directories, and other files. For example, we can select a standalone PDF to support the selected software parts. We may also provide a name for the crate, as well as the other various crate information. There are also various options that a user may select that affect how the crate is built. After building a crate, we can open it and view the files within. This crate contains our documents that we had selected and our software parts. Additionally, there is the crate manifest file. This manifest file contains information on the crate contents and lists out the information of each of the software components that were selected to add to the crate. Additionally, there is the digital signature section, which contains all of the information required to digitally sign this crate using the certificate that was provided. After this crate has been built and transferred to the recipient will want to validate the crate to ensure the authenticity and integrity of it. The user can simply select the zip file and send it to the server, and the server will return saying that this crate is valid. Finally, we can modify this crate that we just created to demonstrate our application catching when the crate has been modified. What we will do here is go into our software part and simply delete out one of these files. Now that this file has been deleted, the crate is no longer valid as it has been tampered with. We can test this by uploading this modified zip file to our server, and our server will correctly identify that this crate is no longer valid because it does not contain all of the files that were expected. And this concludes our demonstration. We'd like to thank our sponsors for guiding us through this project, and thank you for watching our Collins Aerospace 2019 Capstone demonstration.